Hi, and welcome to the Build Your Own Data Logger course, brought to you by FreakLabs and WildLabs. I'm Akiba from FreakLabs. This is Module 6-2, Assembling the WildLogger. In this module, I'm going to take you through the actual process to thread the cables into the cable gland and assemble the WildLogger into its finished form. Here's a before and after shot of what we'll be doing. We'll be removing the cable harness from its housing, threading the wires through the cable gland, and then reattaching the housing. Then we'll be attaching the cable gland to the enclosure. In this way, we can have a system that's protected from moisture but allows cables to enter the enclosure. I tried to keep the tools simple for this exercise, and also tried to limit it to things you may have lying around. Feel free to substitute more robust tools if you have them though. We're going to use the sensor cable and the cable gland, of course. We'll also be using a toothpick and a box cutter. You can substitute anything with a sufficiently pointy tip for the toothpick. In actual practice, I use my needle nose pliers for this kind of job. Also, you can use almost any kind of a thin knife or razor blade in place of the box cutter, since we'll just be using this to adjust the terminal after we remove them. Here's a close-up view of a crimped terminal. The process of crimping just means you mechanically attach the terminal to the wire using a crimping wrench, just like what electricians use when they make electrical connections. The important part to notice is the locking flange, though. This locking flange prevents the wire from falling out of the housing, and is how we will both remove and attach these terminals to the housing. You can see that when the terminal is inserted into the housing, the locking flange prevents the wire from being pulled out. It takes a significant amount of force to pull the wire out, where you'd either have to destroy the locking flange on the terminal or yank the wire out of the crimp attachment. For everyday forces like vibration or a physical shock like dropping the device, it wouldn't be possible to knock the terminal out of the housing, which is the kind of reliability we want. To thread the cable harness through the cable gland, we'll have to disassemble the cable. The first thing to do, which is very important, is to take a picture of the cable harness. This way, if we ever forget the sequence of the wires in the cable harness, we can just refer to the picture. When I'm doing teardowns or disassembly, I take a lot of pictures in case I forget how things go back together. To prepare to remove the wires, hold the wire you are targeting near its base. Then push it into the housing slightly so the locking flange isn't jammed up against the wall it locks against. This is important because we want to push the lock down. If it's jammed against the wall, we just deform the locking flange and make the wire even harder to pull out. Next, you take the toothpick or pointy object of your choice, place it on the locking flange, and push down until it's below the wall. Once it's pushed down, use your other hand to gently slide the wire out. Once you finish the first one, repeat this for all wires. Once you have the wires out, we'll proceed to go ahead and thread them into the cable gland. Loosen the front compression fitting on the cable gland so the wires can go through. Also, remove the rear mounting nut for the cable gland. Take care to leave the black gasket on the cable gland, since we want the gasket on the outside of the enclosure, where it can prevent moisture from getting into the enclosure. Once the cable gland is ready, insert the wires in the front, making sure the sensor will be outside the enclosure, while the cable terminals will be on the inside. From the cable gland point of view, the sensor would be outside the front compression fitting, and the terminals will come out the back side of the gland, where the rear mounting nut goes. When that's done, mount the cable gland onto the enclosure. Attach and tighten the rear mounting nut so the cable gland is firmly held on the enclosure. At this point, I like to adjust the locking flanges. When you push them down, they get slightly deformed, where they'll settle at a lower point than where they were originally. This means that there's a higher possibility the wires can fall out on their own due to vibration or random movement. In this case, I take a box cutter or penknife, slide it underneath the locking flange, and gently jiggle it to work the cable flange up more. The higher it is, the more it'll lock in place and keep the wires inside the housing. I wouldn't go past 45 degrees though. With that done, reinsert the wires into the housing. You'll need to take care that the wires are reinserted in the proper sequence. When the wires are all inserted, it should resemble the original picture you took of them. Double check to make sure they're all in the proper order. If they aren't, you could damage the board or the sensor. Attach the cable housing to the correct terminal on WildLogger. For the temperature and humidity sensor, that would be in the sensor 0 connector. When that's done, repeat the same steps for the PIR sensor. With both sensors mounted inside, you can tighten down the front compression fitting so that it'll close the internal claw around the wires. At this point, you should have a tight seal around the cable harnesses. And from here, you can close up the WildLogger. Your system should look like the above picture. Based on how you decide to mount the sensors, you can use the ruggedization ideas from the earlier modules to protect them from the elements. Congratulations on being able to disassemble and reassemble cable harnesses. It'll be a very useful skill, especially in the field. I hope you have a better understanding of how to harden and ruggedize field devices now. The ruggedization is not just relevant to designs you create from scratch. You can also use the techniques to harden consumer devices you purchase so that you can deploy them in the field. Ruggedization is all about knowing what options are available, as well as a couple of tricks and techniques. Unfortunately, a lot of it isn't common knowledge, so most people learn based on trial and error. But understanding what product designers use to weatherproof and ruggedize field equipment will hopefully help you understand the options and give you more confidence that you can make your field devices resilient in harsh conditions. Coming up in Module 7, Jacinta will take you through our process of testing and piloting field devices and what practices we use to prepare for it. Stay tuned for Module 7, Testing and Piloting.